If we had u is equal to kxy, and we were to solve for x, that means we need to isolate our x. When we have multiple letters smushed together, that means they are being multiplied. So there's the invisible multiplication sign. We want to do the inverse or undo the multiplication. So the inverse or opposite of multiplying k and x and y would mean that we're going to be dividing. I want to get x by itself, so I'm going to divide by k and y. What I do to one side, I must do to the other side so that we can have the equation stay balanced. This would be the division property of equality. Anything divided by itself is a 1. So k divided by k is a 1. Y divided by y is a 1. So on the right side, I have just 1 times x times 1, which means x. On the left side, I have u divided by k times y. These are different variables. I don't know what u, k, or y are, so I'm just going to leave them as they are. In this case, I have k divided by a is equal to w minus v, and I need to solve or isolate the a. I don't want to have my a, my variable, in the denominator, so I'm going to undo, or I'm going to do the inverse, which means I'm going to multiply both sides by a. What I do to one side, I must do to the other side. That is to keep both sides of the equation balanced. So this would be the multiplication property of equality. I am multiplying both sides by a. Whole numbers are really over 1, so I would have a times k all over 1 times a, and anything divided by itself is a 1. So a divided by a is a 1, and so we've got k over 1, which is just k. On the right side, we have a is being multiplied to w minus v. I do not want to multiply out the a because I want to get a by itself. So because this is, the parentheses are telling me multiplication, a is being multiplied to all of this, I'm going to want to do the inverse. I'm going to do the opposite. Instead of multiplying a to the w minus v, I'm going to divide by the w minus v. If I divide by w minus v on the right, I need to divide by w minus v on the left. That is the division property of equality. And so we have a w minus v divided by w minus v, which means that this goes away. It just becomes 1. So it would be a times 1 over 1. A times 1 is a. A divided by 1 is a. A then is equal to k over w minus v. In this case, we have cx on the left side. That is one variable term. We don't know what it is, depending upon what the values are for c and x. On the right side, we have a d as a variable term and a positive r as another variable term. I am unable to combine any of these because they are not the same variable, and I'm wanting to get c by itself. So I see that c is on the left side. I'm going to ignore the right side. I don't care about that. I want to get c all by itself. So what is happening to the c? It's c smushed together with the x, which means that it's being multiplied. So I'm going to do the inverse. I'm doing the opposite. I'm going to divide by x, because anything divided by itself is going to be a 1. We're not dealing with 0. And if I divide the left side by x, I need to divide the right side by x as well. C times 1 divided by 1 is just c. and that will equal d plus r all over x. In this case, we have an x, a negative c, a d, and a positive r. And we want to get c by itself. So I see that the c is on the left side, and so I'm going to look and see what other terms are there besides the negative c. We've got this extra term of x. I need to get rid of it so I can subtract x's from both sides. X take away x is gone. So I have a negative c is now equal to d plus r minus x. I can't combine d, r, or x as they are all separate, different types of variables, different letters. So I cannot put them together. I'm just going to leave it as d plus r minus x. I am not yet done because c needs to be alone, but I still have a negative. So I can either multiply or divide by a -1, and that's going to change the sign of all of these terms. So dividing every term by a -1, negative divided by a negative is a positive, which will get us c. A positive d divided by a -1 is a negative d. Positive r divided by a -1 is a negative r, and a negative x divided by a -1 is a positive x. So c is equal to negative d minus r plus x. In this example, we have z is equal to y plus xm, and we are solving for x. On the left side, we only have z, so I'm not going to focus on the left side because that's not where the variable that we want to isolate is at. On the right side, we have a y, and we also have a positive xm. So on the right side, we have two different terms. We have our y term and the xm term. I want to get our x all by itself, so I start by working to get the x term all by itself, meaning I need to get rid of the other thing, which would be the y. To get rid of a positive y, I'm doing the inverse, the opposite, which means I'm going to subtract y from both sides. Z take away y, I can't put that together. There's no way for me to combine them. They are different letters. Even though they are both variable terms, they are not the same. So I have z minus y on the left side. That is equal to y take away y is 0. I don't need to note that because we also have the xm on the right side. Now that the xm is our only term on the right side, I need to break apart this xm. If I have two letters smushed together, that means it is an invisible multiplication. And so I need to do the inverse. The inverse operation of multiplication is division. So I'm going to divide both sides by m. The division property of equality means what you do to one side, you must do to the other. I'm dividing both sides by m. On the left side, I just have z minus y all divided by m. I can't clean that up at all. On the right side, m divided by m, they become 1s. So x times 1 is x, divided by 1 is still x. So x is z minus y divided by m.